In section 11.3 here, we're going to kind of shift gears. We've been talking about areas of figures. We're still going to talk about areas of figures, except now we're going to look at ratios of similar figures. Remember, we covered this back first semester. Similar figures are figures that have a common scale factor, okay, or a common ratio of sides. And so we're going to use these ratios to help us find areas, perimeters, side lengths, and various things. So here's the crux of the section. Okay, if two polygons are similar with the lengths of corresponding sides in the ratio of a to b, then the ratio of their areas is a squared to b squared. All right. So the side length. So for example, in here, if this guy is a and this guy is b, the ratio of the side length of polygon 1 to polygon 2 would be a over b. And so the areas then, the ratio of the areas has to be a squared over b squared. Okay, and so it should make sense. You know, the way that I always remember this is very simply the units on area are units squared, and so the ratio is always squared as well. Alright, so in the diagram, triangle ABC is similar to triangle DEF. Find the indicated ratio. Part A says the ratio of shaded to unshaded of the perimeters. Remember, the ratio of the perimeters is the same as the ratio of the sides. Okay, so you'll notice here, remember, it goes back to corresponding sides. So it says ratio of shaded to unshaded. So here's my shaded figure. I know that DF is 9. DF corresponds to AC. Good news is we know AC is 6. So the ratio of the perimeters is 9 over 6, and we reduce that down to 3 over 2. Okay, so now if we want the ratio of the areas, well, again, the ratio of the perimeters is the same as the ratio of the sides, and so all I have to do is take that ratio now, 3 over 2, and square it. 3 squared is 9, 2 squared is 4, 9 over 4, and 9 over 4 can't be reduced down. There's nothing that divides evenly into 4 and 9 at the same time. So the ratio of the areas here would be 9 to 4. Okay, you buy 2 rectangular pieces of aluminum window screening. One is 15 feet long and costs $135. The other is similar in shape and is 20 feet long. The screen is sold by the square foot. What is the cost of the longer roll? Okay, so what you need to look at here is the ratio of the sides. The ratio of the sides here is going to be 15 to 20, which is, reduce that down, that's 3 to 4. So the ratio of the sides is 3 to 4. Now the trick here is that they tell you that the screen is sold by the square foot. Okay, so that tells me if it's sold by the square foot that they're charging me based on the area. Okay, so I can't use this ratio to set up a proportion. I have to use my area ratio. If the ratio of the sides is 3 to 4, then the ratio of the areas is 3 squared to 4 squared, which is 9 over 16. So that's the ratio I have to use. So when I set this up, I have the 9 over 16 equals, and remember, they gave us the price of the smaller one, so the 135 has to correspond with the 9, and the x, the cost of the bigger one, is what we're trying to find. Cross multiply, so you get 9x equals, let me just grab a calculator really quick. Alright, so we have 135 times 16, which is 2,160. Divide both sides by the 9, and x equals $240 for the bigger door, or for the bigger window screen. Alright, in example 2, suppose you decide to buy a different kind of screening, but in the same dimensions. The longer roll costs $200. What is the cost of the shorter roll? Okay, again, so your ratio is still 9 over 16, except now they give you the price of the longer roll. So the 200 has to correspond with the 16, so it's got to be on the bottom. X is on top, so you have 16x equals 9 times 200 is 1800. Divide both sides by 16, and the cost of the smaller roll here would have to be $112.50. That's a 5 and a 0. Sorry about that. Alright, a large rectangular billboard is 12 feet high and 27 feet long. A smaller billboard is similar to the large billboard. The area of the smaller one is 144. Find the height of the smaller billboard. Okay, so here's the deal. We know the area of the small one. We can find the area of the larger one since it's 12 by 27. So the A of the larger one, I'll just put AL. So area of the large one is 12 times 27, and 12 times 27 tells us that the area of the larger billboard is 324 square feet. Okay, well here's the deal. Now I can find the ratio of the areas. The ratio of the smaller one, I'm going to do ratio area equals the smaller one over the larger one. And when I reduce that down, let's see here. So 12 goes into 144 12 times, 12 goes into 324 27 times. That's not enough. 3 goes into both those. 3 goes into 12 4 times. 3 goes into 27 9 times. So that's the ratio of my sides. So now I know that when I look at this, that's the ratio of my areas when I break it down. So then the ratio of my sides is just going to be the square root of that. So the square root of 4 over the square root of 9, because we're going the other way now. So that's 2 over 3 is the ratio of the sides. Alright, let me erase some of this to give myself a little bit more room here to work now. So now that I know the ratio of my sides is 2 to 3, okay, smaller one to bigger one, then I know that I can use that ratio to find the height of the smaller billboard. Since I'm looking for the height of the smaller one, the H will be on top because it's got to correspond with the 2. And I knew that the height of the larger one was 12. So I cross multiply here, I get 3h equals 24, divide both sides by 3, and we get the height of the smaller billboard to be 8 feet. Okay, so again, it all depends on what you're given. There has to be enough information to determine the ratio of either the sides or the areas, and then you use this relationship, the square or the square root, to find the other one and solve. Alright, again, at this point I would probably pause the video and see what you got here on your own, but that's just me. So, example 5 says, a stop sign rug is a rectangular octagon. Each side is 2 feet, and the area is about 19.3 square feet. You make a stop sign mat with a perimeter of 72 inches. Find the area of the mat to the nearest tenth of a square inch. Okay, so we're trying to find the area. Okay, what do I know here? I know the perimeter of the stop sign mat is 72. That means I can find the length of a side because it's an octagon. So I have 72 divided by 8. Tells me each side is 9 inches. Okay, and so now, let's see here. I know the rug is 2 feet, each side's 2 feet, which is 24 inches, so I can find the ratio of the sides now. I have 9 inches over 24 inches. 9 over 24, 3 goes into both, so 3 over 8 is the ratio of the sides. If that's the ratio of the sides, that means the ratio of my areas has to be 3 squared over 8 squared, which is 9 to 64. So that's the ratio of my areas, 9 to 64, when I compare the mat to the rug. So now I'm going to use that new ratio that I have now. So again, the 9 over 64 is the ratio of my areas. Alright, so I'm going to use that 9 over 64 here. So the way I set this up, I know the ratio of the areas is 9 to 64. I know the area of the larger one is 19.3. And I want to know the area of the smaller one. Cross multiply, you get 64x equals 9 times 19.3, which is 173.7. Divide both sides by 64. So you're divided by 64, and you get 2 point, and again it says to the nearest tenth of a square inch, so 2.7 square inches would be your area of the mat. Alright, so again, this section is kind of a little bit quirky, but at the same time, hopefully you understand how to use these ratios now, and you guys can go ahead and do example 6 on your own and bring those to class. And any questions, as always, have them ready.